This is the 3D Systems SLS 380. This is our newest production system for selective laser sintering. The great thing about SLS is you're able to use real plastic materials that you would use in the molding environment. So real thermoplastics that can be treated and used in the same way that a molded plastic could be downstream. We've introduced the SLS 380 to solve the problem of thermal consistency and part repeatability for end-use parts. This is our new 100-watt water-cooled CO2 laser. As with any optically based additive manufacturing system, the thermal stability of the optics is of utmost importance. What we've done on the SLS 380 in the introduction of this new system is have 8 individually controlled heaters within the build chamber, as well as a high-resolution IR camera that has the ability to take 100,000 IR data points per second and control those individual heaters to create a thermal gradient that's more homogeneous throughout the build chamber. Now, the print process is only part of the story here. We've also introduced a Material Quality Center, an MQC, that allows us to store, mix, and manage the powder for up to 4 printers at one time. We've teamed up with AMT, a leader in additive manufacturing post-processing, specifically for depowdering and chemical vapor smoothing. What that allows us to do is, with a one-stop shop, you're able to produce a part that looks and feels like a molded part. So what does this thermal stability mean from an end-use product standpoint? What it means is that we're going to get better consistency within one part as well as across a number of parts within the entire build chamber. What this means from a production standpoint is we're going to get improved yields, improved surface finish, as well as improved dimensional stability, ultimately higher yields in a production environment.